Problem 17. Problem 17 says, in the land of Markovia, there are three cities, A, B, and C. There are 100 people who live in A, 120 who live in B, and 160 who live in C. So, all right. So, uh, yeah. So there's A, B, and C, right? And so there's 100 people who live in A, 120 live in B, and 160 live in C. And everyone works in one of the three cities. So, and the person who may work in the same city, and the person may work in the same city where they live. So, um, um, so it's like there are three cities, and then there's so 100 people live in A, and then 120 people live in B, and then 160 live in C, right? And then everyone works in one of the three cities. So you either work in A, B, or C, and then a person may work in the same city where they live. So a person might not work in the same. So a person may work in the same city where they live, right? That means they might not as well, right? So it says in the figure below, an arrow pointing from one city to another is labeled with the fraction of people living in this first city who work in the second city. So so in order to understand this, it says, for example, one fourth of the people who live in A work in B. So you see here this arrow connecting A and B. That means that that means that one fourth of the people who live in A work in B. So I guess to understand this really, right? We can think of it like this. So where the arrow ends, so like where the arrowhead ends, is where I guess we could think that. My bad. So where the arrowhead ends, I guess, is the place where we could think that they work from. So you see the arrowhead ends here. So that means that they work at B, but then the tail of the arrow starts at A. So they live at A. And so if we were supposed to be thinking about I don't know, say, let's say this arrow, right? This arrow starts at C, the tail of the arrow is at C. So we're going to say that the people here work in C, or live in C, but the arrowhead ends here, so they work in A. So arrowhead, I guess I'll just write the symbols, right? So it says this means that they work, and then if the arrow's like that, this means that they live. Right. So the tail of the arrow tells us, or where the arrow starts from tells us where they live, and then where the arrowhead ends is where they, work for, right? Oh, okay, yeah. Um, so it says how many people work in A, right? So in order to answer this question, we'll have to think about this for a second. Do you guys have any ideas on how we could possibly approach this problem? Because there's a couple of ways we could go over this. But any ideas on what to do? Or okay, so I guess we could kind of start this problem by, so you see that there's 100 people who live in A. Well, okay, so 100 people live in A, but do those 100 people work in A? Think about it. Like, uh, if the 100 people, if say I'm part of the 100, I live there, but do I work at A? Well, no, right? Because as we said, this is where you work. So where the tail of the arrow, or where the head of the arrow is, right? The pointy side. That's where they work, right? So as you can clearly see here, which two arrows which two arrows clearly signify the amount of population that don't of those 100 that don't work at A? You see this arrowhead, and this arrowhead. These two arrowheads clearly point away from A, and they point towards B and C. That means that those travelers, they don't work at A, they work at, or they live at A, but they don't work at A. They go somewhere someplace else, and then they work there. So that means that one-fourth of the people that uh one-fourth of the 100, right? So one-fourth of the 100 don't work at A, plus a one-fifth of the 100 don't work at A, but live in A, right? So because you see that the arrowhead, tails of the arrow, they point at it, they point from A, right? So they don't live in A. So that means that a total of 45 people work in A but don't live in A, right? And but that means that the rest 55 work and live in A. But think about it. Are we done here? Are we done here? Well, no, right? Because we have to count the number of people that live in maybe say cities B and C, but then go to work at A. So how many people of that kind exist, right? Well, you see that there's one third here because remember this tail, this arrow, their tail is on B, so they live in B, but they go to work at A. And then the 1/8 here, they live in A, or they live in C, but they go to work at A. So one third, what's the population of B people? There's 120 people who live in B. So one third of the 120 people that live in B don't work at don't work at B. They work in A. So that means that there's 40 people of that sort that live in B but work in A, right? 40 live in B but work in A, right? And then as you see again, there is 1/8 of the people, right, like right here that I marked, that live in C but go to work in A. So that means what's the population of C? C is 160. So 1/8 times 160 is going to give me 20, and of the same sort that live in C but don't work but work in A. So that means that gives us a total of 20 people here, 40 people here, and 55 people here. So that gives it a total of 115 because 20 plus 40 plus 55 is 115 people. So 115 people go and work in A. Does that make sense to everybody? Please let me know if that doesn't make sense to you guys. By the way, I should have gone over this, but let's go over it now. So, what do these fractions depict? These fractions actually depict the number of the populations that the populations of A that go to work in different places, and this fraction depicts the populations from B that go to work at different places. So this fraction shows me that one-fourth of the people from A go to work in B. This fraction shows me one-fifth of the people from A go to work at C. This fraction shows me one-third of the people from B, right? Because the tail is here. One-third from B go to work at A. It's not like they're not very dependent on each other, right? So that's like the misleading part of the figure, right? So I think that's an important part that I should have mentioned. But yeah, so that's what those arrows mean. Does that make sense to you guys? And you guys can actually see that they're not dependent on each other because uh, if you add these fractions up, they will actually not add up to one. They'll add up to something else. And so that's how you know that these probabilities have nothing to do with each other. It's like one-fourth of the people from A and then one-third of the people from B. So that's how we got to that answer. Because we saw that one-third and one-fifth of the people, or one-fourth and one-fifth of the people weren't working at A, they were working somewhere else, but live in A. And then we saw that one third of the people from B go to work at A, and then one eighth of the people from C go to work at A. And so we did that, and we added up the answers and got to our final answer of 115. That made sense, right? If you guys have any questions, just feel free to uh, pop them in the chat, and then Daniel will attend to that. Right. So problem 19. Problem 19 says two towns, A and B, are connected by a straight road 15 miles long. Traveling from town A to town B, the speed limit changes every 5 miles, from 25 to 40 to 20 miles per hour. Okay. Okay. Yeah, yeah, yeah. Okay. So two cars, one at town A and one at town B, start moving toward each other at the same time. They drive at exactly the speed limit in each portion of the road. And so it says, how far from town A in miles will the two cars meet? Okay, so there's town A here, and there's town B here, right? And so traveling from town A to town B, the speed limit changes every 5 miles, right? So it says that the speed limit changes from 25 to 40 miles per hour, right? And then from 40 miles per hour to 20 miles per hour, right? Does that make sense to you guys? That part. I can see that the problem statement might be a bit confusing, but feel free to let me know if that doesn't make sense. All right, so every 5 miles, the speed will change. So I guess from here to here, the driver is going to be driving at 25 mph, and then exactly at this point, the driver will change to 40 mph, and then move somewhere else, right? And then and then after that, it'll again go at 20 mph, right? So something like that, something around that. Right. Okay. So we have to find the speed limit in each portion of the road. Or they drive at exactly speed limit in each portion of the road. So we have to find when the cars will meet and the distance from town A. Okay. So we can see that visually. So this is 5 and this is 5. Yeah. So we can see that visually it looks like they're gonna meet somewhere in between, right? So somewhere in between the 40 mph kind of section, right? So we can see that. But exactly where is what we have to find, right? So the road is 15 miles long. We covered that. Yeah, yeah. So 5 plus 5 is 15. Right. So they're going to meet somewhere in the 40 mph road. Well, let's try to find out where they meet, right? So first of all, let's try to find out uh, how much time has passed once A crosses the 20 and 25 mph section, right? Because visually we can kind of see that they'll meet in the middle, right? So let's talk about like how much time A takes to cross like the first portion of the journey. So this he travels for 5 miles at a speed of 25 mph. So that'll give us one fifth of an hour, right? That makes sense to you guys? Why that's 1/5 of an hour? Because it's just 5 miles over the uh, or distance over speed. My bad. A distance over speed equals t, right? So that's the beginning of the journey, and then let's find actually B's I guess time to cross the first part of his journey as well. So he's going from this side and moving towards there, right? So he'll take 5 miles over 20 mph, right? So that's gonna take like 1/4 of an hour, right? So that means that there's a discrepancy between what A travels and what B travels. A is going faster, so 1/5 of an hour is like 12 minutes, I think. Yeah, 12 minutes, and then this is 15 minutes, right? So we can see that B takes longer to cross the first part of its journey than A does, And so how by how much longer? Longer by 3 minutes. So by the time B crosses the first part of its journey, A is already done with 25 miles per hour, and he's in the 40 mph section, and he's gone for he's going there, or he has driven there for 3 mph as well, or 3 minutes as well. So let's find how much distance A has traveled in this part of the part of the, I guess, route until B reaches there. So B just reaches here, but A has already gone some distance, say D, uh, towards has moved some distance D towards B. So let's find how much. So 3 minutes is gonna be 1/20th of an hour, right? Right. So 1/20th of an hour times. I shouldn't. Yeah. So 1/28th of an hour times 40 mph, because now she moves at exactly the speed limit, which is 40 mph. So 40 miles an hour. That's gonna give us that she travels 2 miles, right? So she travels 2 miles of the 5 miles that the road is long, right? So, uh, so I guess I can draw here. She travels like, it's getting a bit messier, so I'll just erase. Yeah, so this is 4D, and then she travels like this much of the road, 2 miles of the actual 5 miles, right? So that means that the road that's left is 3 miles, 3 miles, right? And and they're both traveling at the same speed. What that means is that if they're both think about it like, just think about this, right? So I have two cars. So let's say this is car A, this is car B, right? I have two cars. They're both moving at the same speed, V and V, right? At what distance D will they meet? Well, it's logical that they'll meet at distance D over two, right? Because uh, by time T over two, right? So let's say uh, let's say V here has moved the distance D, or yeah, actually, so because we know that distance equals V times time, right? So let's say if A was just to travel with speed V over the whole distance D, that would take him like T seconds, right? Say, right? But let's say at time T over two, let's see the distance that A travels, right? So uh, at time T over two, the distance that A is traveling will be D over 2, right? Because VT over 2, we already established that D equals VT, right? That's time is total time, and then distance is the total distance. So at time T over 2, they're both going to be a distance, they A is going to be a distance of D over 2 along its journey. But guess what? B is also moving with the same speed. So what does that mean? B is also going to travel the distance D over 2. So if they both travel a distance of D over 2, right, in the same time interval T over 2, aren't they both going to meet at the middle? So that means that we have already found the answer. The answer is the 5 miles that A travels in the beginning plus the 2 extra miles that A travels in the middle, right? So 2 miles that A travels in the middle while B is still covering its first part of the journey, which is two. But then we what's D in this case? Well, D for which the distance is D over two, that the distance where they meet is gonna start. So I have a 5 mile section here. B just gets here, and then A has already traveled the distance of 2 miles an hour. So that means that A is gonna that the D that we're talking about, the D over, where we can where we can apply the D over two thing, is gonna start from these 3 miles that both cars still have to cover, but at the same speed, right? So they're traveling the same speed, but they still have to cover the 3 miles. So that means that they're gonna meet at 3/2 miles, which is 1.5 miles. So that's gonna give us 5 plus 2 plus 1.5, which gives us 8.5 for D. Did that logic make sense? Uh so again, I guess this, you could just have thought of the distance where they met, because yeah, you could have done it using just T over two, or you could have said that, yeah. So you could have done this as well. So say yeah, say you don't know this one half factor of D that needs to be multiplied, right? Um, and so let's say you have some distance D. If A, so let's say this is ND. A travels ND of ND of a distance, right? So some factor N, right? So if A travels ND, how much is B gonna travel? D minus ND, right? Because whatever A travels, B is gonna travel the rest of the distance because they have to catch up, right? So, but they catch up at the same time, right? Or else they don't meet at the same time, right? They have to meet at the same time, right? That means that ND over V, because they're both moving at the same speed, is equal to D minus ND over V. And since V is the same, V cancels out, and we get N equals 1/2. So that means that at D over 2 they meet. Because remember, if A travels ND, B has to travel N minus ND or D minus ND. But then they both have to make the journey in the same amount of time, right? Or else they're not going to meet at the or they're not going to meet at the same time, right? You can't just have A standing there for some amount of seconds and B comes some amount of seconds after. They have to meet at the same time, and so that's why we said the times equal to each other. So did that problem make sense? That's how you that by the way, that you could either like logically think about this, or you could actually mathematically get to the answer. Both answers will give you D over two. Right. Okay. So let's go over this problem. Problem 21 says the Konigsberg School has assigned grades 1 through 7 to pods A through G, 1 grade per pod. Some of the pods are connected by walkways as shown in the figure below. The school noticed that each pair of connected pods has been assigned grades differing by 2 or more grade levels. For example, grades 1 and 2 will not be in pods directly connected by a walkway. Okay. So what is the sum of the grade levels assigned to pods C, E, and F? Okay. So it wants us to find some sort of construction and then the sum of the grade levels. All right. So each pod is assigned 1 grade from 1 to 7. So there's 7 letters from A to G, and they're each assigned some number from 1 to 7. The school noticed that each pair of connected pods, so let's say A and G are connected, right, has been assigned grades differing by 2 or more grade levels. So you can't have A as being grade 1 and G as being, I don't know, grade 2, as they mentioned here, right? You'd have to have 3 or above. So the problem asks us, what is the sum of the grade levels assigned to pods C, E, and F? All right, so there's a couple of ways of doing this problem. But do you guys have any ideas on how to do it, or if not, I can go over it. But so you could either actually find the construction, or you could just use algebra a bit. But both methods are fine. All right, so uh, let's look at this diagram for a bit. We see that pod A is connected to uh, I guess I'll erase this. Pod A has five connections, or let's see how many connections the pod A has. So pod A has one connection here, one connection here, one connection here, one connection here. Yeah. So pod A has four connections, right? So pod A is connected to four other members, right? So that means that so let's see what that means for pod C. Pod C has one connection here, one connection here, one connection to pod F here, one connection to pod D here, and one connection to pod E here, right? So that means that they are connected to five other pods, pod C, right? Um, so what does that mean? And then it asks for pod. So this is C. Let's count the number of connections that each pod has, right? So E has one connection here, one connection here, and one connection here. So E just has three connections, right? And then F, let's count F. So F has one, two, three, four. Oh, okay. F also has five connections, right? So what does that mean? That means that uh, given the condition, or yeah, so given the condition grades 1 and 2, that means that F and C must contain um, let's say let's say you have grade 1 here, right? So F and C must contain some grades that, or F and C can be grades that are, I guess, differing by one, right? Because C doesn't have any, or wait, no, C does have a connection to F, right? So let's say C has one. Let's look for uh let's look for pods where two could be a viable option. So C has a connection here, so that's not a viable option. C has a connection here. C has a connection to F as well, to B as well, and to A as well. So G is the only place where two can be placed, right? You guys see that? And you guys see why that's the case, right? So G is the only place where two can be placed, right? And so G has only three connection or two connections. So that means A or F cannot be three. That means that E, B, or D has to be three, right? Does that make sense? So actually, by the way the problem stands out, if C is assigned grade 1, what I think is that F has to be 7. I think that F has to be 7, and here's why. Because if 2 is assigned to G, and C is connected to A, B, D, and E, and F, right? And F has the same amount of connections. That means that C and F must be 1 and 7 in 1 and 7 in some order. So C could be 1, F could be 7, and F could be 7, and C could be 1, right? Then, because let's say C is 2, right? Let's say C is 2, then that means that from 2, he could have connections here. So let's say this is let's say this is 4, right? I Because you can't have anything anything with a 1 difference, right? So let's say this is 4. Uh, let's say this is, I don't know. Let's say this is 5, right? Let's say this is 6, and then let's say this is 7. But you see that its connection to A, there's always going to be one pod that has that, or that connects with C, but it's going to be difference of one, because this is gonna have either one or three. A is gonna be have to be A is gonna have to be either one or three because every number is distinct, right? So that means that C and F always, and then same for F because it has the same number of connections. So C and F can never be two, three, four, five, and six. So they always have to be one or seven, right? So let's say that C is one, and let's say that F is seven, because we already know that that's true because they have the same amount of connections, right? We just have to find the number of connections, or we just have to find what E is, and we're done, right? So let's say that we have C as seven. Uh, that means that G, what does G have to be, right? Um, so G, so let's look at D, I guess. So you see that D is like the only pod that's not connected to F, right? So that means D must be six, as I wrote here, because if you're not connected to F, then you must be six, right? Because you must be the number that's equal to one. Otherwise, that'll contradict, right? If you have if E is what E if E is six, F is connected to E, that's not a viable option because grades one and two or equal to one difference must not be connected to each other, right? So D is six, and then similarly, as I mentioned earlier, G is two, right? This is because of the same kind of logic. And actually, I'll speed through the solution a bit because Daniel has to cover his lesson as well. So that means that we have A, B, and E left. And A, B, and E have to be assigned numbers 3, 4, and 5. Well, let's look at the numbers A can be assigned. Can A be assigned 3? No, right? A can only be assigned 4 or 5. And then let's look at E. Uh, yeah. So let's look at E, right? E can be assigned any of these numbers. But then let's look at B, right? Can B be assigned? Can B be assigned any? What numbers can B be assigned? Let's look. So look, if A is assigned any numbers from, if A can't be assigned A, yeah. So let's say A can't be assigned three, right? A has to be assigned four or five. But look at B. B and A always have to differ by more than one because they're adjacent, they're connected, right? So that means that if B is say a three, A has to be five. Because A can't be three because G is right next to it, but A can be five and then B is three. B can be four because A is connected to B, and that's a difference of one. So we know that E is four, the only number remaining, and so we know that C plus E plus F will give us 12. So yeah, that's the answer. And sorry if I bit went over a time, Daniel. But yeah, that's it for me. Just think about the last problem for a sec. Just think about the last problem because it was a bit of a harder problem. But yeah, so I'm sorry if I rushed the solution a bit, but we're running over time. And so with that, I'll turn it over to Daniel. Thank you guys.
Yeah, I'll get Sid. I'll get Sid. I actually really like that problem because if you guys want to like look more into like connections and this kind of like problem solving stuff, you guys can search up graph theory. I know Sid is a very big fan of that. Yes. So yeah. So yeah, search up graph theory if you're interested in that kind of problem. And yeah, I kind of like that. I also kind of liked how you can just like narrow down the possibilities for CAF and go from there. And so my mirror's loading. I'm gonna screen share now, and we'll go over all the even number problems. Start from 14. Needs a little bit lag. I'd say. Let's wait for this. Take a while. All right. Problem 14 reads a number n, trying to scroll here. A number n is inserted into the list 2, 6, 7, 7, 28. The mean is now twice as great as the median. What is n? Okay. So so basically when I see these statistics problems, I like to form an equation because if we have an equation, we can just solve for n. And so um, what the main information that this problem tells us is that the mean is now twice as great as the median after n is inserted. But we don't. But the problem is, a little problem is that we don't know what n is. Um, and so if there are a couple ways to think about it, but I guess there's the shorter way. I'm gonna actually uh, give you guys a shorter way. Shorter way to think about it is to actually look at the answer choices in this one. I know I either like me or Sid like repeat this like strategy of doing the problem first and then covering the answer choices, doing the problem and then selecting the answer choice. But sometimes like again you can like exploit the answer choice and that can actually help you solve the problem, especially when you don't know like a property because like we don't know what the median is after we insert n. So let's just like try out some yeah yeah, yeah. Let's just try out some values for n and see what the median is, because again we don't know what the median is. So let's try a. Okay, obviously we don't know the mean yet, but let's just see what the median is because we don't know what the median is after inserting n. So if n equals 7, then the list is going to look like 2, 6, 7, 7, 7, 20, 28. Okay, and the median is 7. Okay, that's nice. Um, let's try 14. Again, we just want to get the feel of the problem. What is the median? Because n is a number, we want to like make the problem more concrete. And so we just try out values for n. So n equals 14 gives us 2, 6, 7, 7, 14, and 28, noting that there are two sevens. Okay, so the median is also it's I think I meant to say it's there obviously I kind of think I skipped over this, but there are 6 values in this list after inserting n, and the average of the middle two terms because the number of terms in the list is even. The average of the middle two terms is the median. So the median actually comes from the average of 7 and 7, which is just 7. And so here, if we insert n equals 14, we also find that our median is 7. So that like makes us suspect like if like for all of our answer choices, because if we try n equals 20, then it's also going to go here. It's not less than 7, it's not greater than 28. It has to go here. And even if we go, if even if we have like 28, if we try n equals 28, our list is going to look like 2, 6, 7, 7, 28, and 28. And then we just inserted it after 28. And what's the median here? Median is just the average of the middle two terms, which is a 7. And so actually, we can say that the median is just 7 because like if we and I guess we can kind of like prove this by like listing out the edge choice, but intuitively if we think about this list and seeing that the smallest entry choice is 7, then we can say that the median is always going to be the average of 7 and 7, which is just 7. Because if even if we insert 7 itself or anything larger, it's going to have to go somewhere here, somewhere in this area, which doesn't really affect our median. And so we can actually say in this case that the median is 7. So the problem becomes really easy now because look what we can do. Let's use this second sentence right here. The mean is now twice as great as the median. And so what is the mean here? The mean, if you recall from one of our previous sessions, the mean is the average of the 6 numbers. So the average value of the list. And the mean is just the sum of the 6 numbers. So it's going to be 2, 6. I'm just going to write the sum actually, just to save time. 2 plus 6 plus 7 plus 7 plus 28. So those are the 5 numbers plus n, all over 6. So it's going to be the sum of the numbers in the terms divided by the number of terms, which is 6, after inserting it. And so that's our average. And it says it's twice as great as the mean. So since the mean is, median. Since the median is 7, we can say that the mean, right? This quantity is our mean, is twice as large as twice as large as our median. And we kind of like proved, sometimes it's called cheesing. We kind of like cheesed our way that like the median is 7. And so we can just solve for n in this equation. All right, so again, this is just a simple linear equation. So multiplying by 6 on both sides gives us 6 times 2 times 7 on the right-hand side. And that is equal to 12 times 7, which is 84. And after multiplying by 6 on both sides, you're going to get the top sum, which is 2 plus 6, which is 2 plus 6 is 8. 8 plus 7 plus 7 is 14. And you're going to have a 28. So it's going to be, I'm just going to write 8 plus 14 plus 28 plus n. All right. And so 8 plus 14 is 22. And then you add another 28. That gives us 50 plus n equals 84. And so 50 plus n equals 84. Subtract 50 from both sides, you get n equals 34. And that's your answer. So n equals 34 is our answer. And we can see that even if we insert our new number, right? 2, 6, it's going to look like 2, 6, 7, 7, 28, and 34. We can verify that the median is 7 because it's just the average of the middle two terms. And since the middle two terms are the same, the average is just 7. All right, let's check our work with the answer key real quick. This thing's not loading. I was just going to move on to the next problem. And so problem 16 reads, and I'll check the answer once the website actually loads. And so problem 16 reads, 5 distinct integers from 1 to 10 are chosen, and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. So what is the sum of the 10 chosen numbers? All right. All right. Let's see. So the interesting thing, the interesting condition, right? And E equals 34 is correct. So I just checked it with the answer key. So no two numbers. The fact that no two numbers differ by exactly 10 is really interesting, and because like that's basically like the main constraint from for like choosing 5 numbers from 1 to 10 and choosing 5 numbers from 11 to 20. And so for this problem, we can actually just find a way to pick 5 integers from 1 to 10 and 5 integers from 11 to 20, such that they don't differ by 10. And so we can just find a way to do that. So how would we do that? Because there is a constraint, right? So a good problem solving strategy is to look at the constraint. So if there's some wacky thing like no two numbers differ by exactly 10, what does that actually mean? Let's just try out, play around with a couple of examples. So if I give you two numbers, 3 and 14, do they differ by 10? Do they differ by exactly 10? And I'm playing with numbers from by picking a number from 1 to 10 and 11 to 20. So do they differ by 10? Well, it's easy to see that 14 minus 3 is just 11, and that's not 10. So no, they don't. How about 5 and 17? Well, by the same reasoning, 17 minus 5 is 12. You can't do that. But how about 4 and 14? Do they differ by 10? Yes, because 4 plus 10 is 14. 14. And alternatively, 14 minus 10 is 4. So they do differ by 10. Now, do you observe something interesting? Let's just try one more example. If you have 1 and 11, do these differ by 10? 11 minus 10, 11 minus 1 is 10. 11 minus 10 is 1. Yeah, so they do differ by 10. So notice something interesting about the units digit. And this is like the units digit is often a very common theme in AMC like number theory problems. If the numbers, like if you pick a number from 1 to 10 and another number from 11 to 20 and they differ by 10, then they have to have the same units digit. That's the key observation. Or the only exception, yeah. Because even with like 10 and 20, right? Even with 10 and 20, I was thinking about this one just to like check. 20 minus 10 is 10. So since the difference between 10 and 20 is 10, the rule also works for 10 and 20. And so if we think about it, picking if we pick the 5 numbers from 1 to 10 and if you pick the 5 numbers from 1 to 10 and you need to pick the other 5 numbers from 11 to 20, the 5 numbers they pick from 11 to 20 are actually fixed. And let's see how. Let's just write out all the numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then from 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. And so notice that if no two numbers differ by exactly 10, then we can't have a column that is chosen, right? I can't choose both 1 and 11 and then have this condition be satisfied because 1 and 11 both differ by 10. So for each column, we actually need to choose exactly one number from each column. And the other constraint is that like when we pick the 5 numbers, right? We have to pick 5 numbers. So let's actually just choose any 5 numbers, right? 3, 6, 7, 8, and let's say 10. If we pick 5 numbers from here, notice that we can't pick 13 because we picked 3 from 1 to 10. We can't pick 16. We can't pick 17. We can't pick 18. We can't pick 20. And so, and since we also chose the 5 numbers, right? We need 5 numbers in this range from 1 to 10 and 5 numbers in the other range. We also can't pick 9, 5, 4, 2, and 1 because we already picked 5 numbers. Why would you need to pick any more? And so our remaining numbers will need to be picked because there are exactly 5 remaining numbers. There are exactly 5 remaining numbers in the other range, and yeah, you just pick those 5 numbers, and that's it. And you can actually like prove that you will only need to pick the five numbers to kind of fix it. And so we can just find the sum of this. Now there is the nice thing about this problem is that you can pick the 5 numbers in the first range at will, and the second number, the numbers in the second range will be fixed. And so we can actually choose how we pick the 5 numbers in the first range. just to like make our sum easier, because we're always going to get the same sum, and we can actually prove this. Um, but let's just like try to get the answer in the most efficient way possible. Um, we gotta we gotta pick five numbers. Sorry, what? Five numbers from 1 to 10, and five numbers from 11 to 20. So let's just try to like make the numbers a little bit easier on ourselves. We can try. Let's see. We can try. Um, if we pick 11. Uh, okay, I'm gonna list the numbers in the second range. Uh, to the right of the number two, and similarly for the number one. So if we pick 11, this is something, this is kind of like comes with a little bit intuition, but you can see what I'm doing, or like learn from what I'm doing, because I think this will be a little bit easier just to add numbers. So if you pick 11, you can't pick one, right? And so I'm gonna pick 10, and you'll see why in a sec. Okay, but you can pick 12. Uh, you can pick 12, but you can't pick 2 in the first range. And I'm gonna pick 9. Pick 13. Again, I'm picking from the second range, but again, if we pick 5 numbers from the second range, the 5 numbers that we pick from the first range will be fixed. And so if we pick 13, I'm gonna pick 8. And if we pick 14, I'm gonna pick 7. And finally, if I pick 15, I'm gonna get 6. All right. And so notice that these numbers and these numbers all don't have the same units digit, and so we can be sure that this is a um, valid group, a valid selection of 10 numbers from these two ranges. And so look at now. Notice why I set it up like this. 11 and 10. What is the sum of 11 and 10? Because we want to find the sum of the 10 numbers that we just picked. 11 plus 10 is 21. Okay, I'm going to write the summers here. And I'm going to do the same thing for 12 and 9. What is the sum of 12 and 9? That's 21. Ooh, 13 and 8? That's 21. 14 and 7? That's 21. 15 and 6? That's 21. So we have 5 pairs of numbers that sum to 21. So that the problem just becomes 21 times 5, which is 105. So that's just like as I think like would be a really nice shortcut in the context, because obviously like you could just like after you make the key observation that, oh, the units digits can be different, um, you could obviously like add up uh, any valid group of 10 numbers, right? Like you could add up the numbers over here that we just circled, but sometimes there's an easier way to add up the numbers, and so that's something I think you guys should definitely see and apply to future problems, because you never know if a similar idea comes up in the future. Okay. Um, let's see. I don't think I will have time to actually finish this one, but let's just read over it real quick. And maybe I'll finish it, maybe not. And I'll continue. If not, I'll continue it in the next session. So the circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and the inscribed square is shaded. The shaded regions in the two circles have the same area. What is the radius r in units of the circle on the right? Okay, so all of that, like all of what I just read is just kind of like saying what's the like it's really nice because they give you a diagram, right? If they didn't give you a diagram, you have to draw it out, and that would be a hassle. And so the nice thing here is that the we can how we start about this. There's always this one key sentence that gives you the equation, and you can solve for like r, like what you want to find, like n or r or some variable. Here, the key idea or the key sentence is reads the shaded regions in the two circles have the same area. So let's just find the regions of the two shaded regions. And so what's the shaded region of this? Well, the shaded region is just the area of the circle minus the area of the square. You guys see that? Because we're taking the circle. If you can think about like cookie cutting. If you have a circle cookie and then you kind of like cut out a square out of it, you're gonna get the shaded region. Um, okay, well now what about this one? Well, we can actually do the same thing, right? The shaded, or almost the same thing. Shaded is just circle, the area of the circle minus the area of the square. And then after that, you're gonna get, like after doing that, you're gonna get this part. So now, what's the area of the shaded region? You're just gonna divide that by 4, because each of these 4 pieces right over here is the same by symmetry. And so you can say that we already have, we can just develop the formula circle minus square over 4. And so the outline, I guess I'll finish it. Let me see. Okay, I can do it in 3 minutes. Yeah, so basically the shaded region is just, this does require a little bit of knowledge to find the side length of the square, because yeah, so if we draw a segment like that, you're gonna form a right angle um, between like these two segments. So this, if you recall your Pythagorean triangles, 1 root 2 is a common one. So the side length of the square is root 2, and square that to get the area of the circle. And since the radius of the circle, oh sorry, my bad. I was finding the area of the square. So you're subtracting the area of the square here. And so the area of the circle is just pi times 1 squared, because the radius is just 1. And so this gives us pi minus 2. All right. Now let's just do the same thing. The area of the circle is pi r squared. The area of the square is, instead of 1, we're going to have r root 2 as the area of the square. R root 2 as the side length of the square, sorry. And so setting these two equal, pi minus 2 equals pi r squared minus r squared times 2 over 4. And so we get 4 pi minus 8 equals r squared times pi minus 4. And so you get r squared. After dividing by pi minus 4, is a little bit hard to see, but eventually you get r squared. Oh, this is, sorry, this is a 2. Yeah, this is a 2. After dividing by pi minus 2, you're going to get r squared equals 4, and you get r equals 2. So that's your answer.